This is the screencast for section 3.3, example 2. We are going to use our rules that we're learning for taking derivatives, our shortcuts, and use them to find horizontal tangents. Now I know, you're like, well, Miss Larson, I could just graph this and show you where the minimum is or the maximum or this minimum, so I can do second calc min and second calc max and second calc min, and I can tell you where those horizontal tangents would be because they would have a slope of 0 right there. Well, unfortunately, it's not unfortunate, it's awesome that this is calculus, so we have to use calculus. Okay, well, how do we use calculus to find horizontal tangents of a curve? Well, the horizontal tangent, as I just mentioned, means that the slope equals 0, which means y prime equals 0. So let's find y prime using our rules, and of course you can write that as y prime or dy dx, either one. And now that we are older and wiser and we've been through example 1, I'm going to show you the fastest way to do the power rule here. This would be 4x cubed minus 4x, and then that's plus 0. So really that is all the work that I would require from power rule. But that only gives me the derivative. I need to know where the horizontal tangents are. So their slope, horizontal lines, have slope 0. So I'm going to factor out an x. Oh, actually, I'm going to factor out a 4x. And that's going to leave me with x squared minus 1. So I can further factor this to be able to solve for when the slopes are 0. So x equals 0, 1, or negative 1. Now, the question says, does the curve have any horizontal tangents? So yes, y has horizontal tangents at x equals 0, 1, and negative 1. Now, if you wanted to actually find out what those points were, you could plug them into the original function. So if I plug in these x values, I can find out the y values, and I can show that at 0, 2, at 1, 1, and at negative 1, 1, there's going to be horizontal tangents there. Now the directions don't say specifically at what point does the curve have horizontal tangents. It just says where. So where is when x equals 0, 1, and negative 1. You don't need to do the extra work in this case. Now again, this is the graph of y, and we are in calculus, so we're trying to use the graph of y prime. Y prime has zeros where those horizontal tangents are, at negative 1, 0, and 1 for the x values. So again, a graph wasn't required for this problem, but I just wanted to show you graphically what this means when you're finding a horizontal tangent using the derivative. You're finding the zeros because the slope of the tangents are 0. The now try problem number 7 says find the horizontal tangents of the curve. Okay, now this one says find the horizontal tangents. So those are equations of lines. Now horizontal lines are y equals a number. So in this case, first we're going to find the x values that have horizontal tangents, probably somewhere like there and like there, looking at y. We'll find those x values, and yeah, here I see them on the graph of the derivative. But then it's asking for the equation of the tangent line, so I'm going to have to find the y values and make the horizontal line out of that. So here we go. First and foremost, let's take that derivative. 3x squared minus 4x plus the derivative of x is 1, because that would be 1x to the now 0, and then the derivative of 1 is 0. So I'm going to set the derivative equal to 0 and split up my middle term into the two numbers that add up to negative 4, but multiply to be positive 3. And then I'm going to factor. So I get that the x values where those horizontal tangents are located are 1/3 and 1. Now be careful, these x equals 1/3 and x equals 1 would be vertical lines if you called this your answer. That's not true. We're trying to find the horizontal tangents. So I need to plug in 1/3. So I find that the points where these horizontal tangents are located on the original curve are 1/3, 31/27, so a little bit over 1, and then 1 comma 1. It's not asking me for the points, it's not asking me for the x values, it's asking me for the horizontal tangents. So those are y equals 31/27 and y equals 1. So I use the zeros of the derivative where the slopes equal 0, those x values, to find this location of the horizontal tangents in y, and then I found those y values to find the actual equation of those horizontal lines.